Hi students, coming to the next topic in the dynamic programming approach is the traveling salesman problem. So this traveling salesman problem can be solved by using dynamic programming approach. Okay, so now let us see what is this traveling salesman person. Actually, this problem consists of, let us take the traveling salesman as a problem consists of salesman and set of cities. So the main thing here is we have to take one person, means the person that is visiting all the set of the cities. So here we have to find out the person that traveling to all the cities, and the cost of visiting the city should be minimum. That we have to be calculated. The traveling salesman problem consists of a salesman and a set of cities. Let us take the salesman. The salesman has to visit each city starting from, let us take starting from home and returning to the same city. So let us consider a man has to visit each city starting from home. So here is a man is there in his hometown. He want to visit all the cities and again he return back to his place. Okay, so let us consider. So here is a man. The salesman has to visit all the cities starting from his hometown and returning to the same city. So here the main challenge of this problem is that the person wants to minimize the total length of the trip. Okay, suppose if we want to visit all the cities that are present in one country, okay, so the first thing we will do is first we are thinking which cities we have to be visited, that we have to be selected, and those cities has to be visited. But we will think about the budget also. Okay, so which route, if we go in which route, so that the budget will becomes less, means we can spend less money while traveling. So that path we will be selected. So the person wants to minimize the total length of the trip. So that is the main challenge in the traveling salesman problem. So the tour is to be simple path that starts and ends at a vertex 1. Suppose the person is only at the present vertex, means at his home. The tour is a simple, means he is visiting his own place, means the traveling cost is 0. The traveling cost is 0. If you visit the same place, means the starting vertex and the end vertex are both are the same, means the cost of the traveling should always be 0. Now let us consider, let g of I comma s. Okay, so I, let us take, is the starting vertex and s indicates the set of the cities. Starting city and s indicates the set of the cities. So that will be present in a graph. Be the length of shortest path starting at vertex I. So this represents the length of shortest path starting at vertex I, going through all vertices, means going to all the cities in S consisting of set of cities. Okay, so starting from vertex I, first city, and going through all the cities in S and terminating at vertex 1. Okay, so whatever I said here, so that I represented in the form of g of I comma s. So this is a graph, this consisting of this starting city and the set of all the cities. So this represents the length of the shortest path. And the function let's take the function g of 1 comma v minus of 1. So this function represents is the length of the optimal salesperson tour. Optimal salesperson tour. Okay, so let us take this is an optimal search, the length of the optimal search by a person, and from the principle of optimality we can find out the formula for calculating the shortest path by using the traveling salesman person is g of 1 comma v minus of 1 is equal to minimum of 2 less than I less than k less than equal to 1 less than or equal to k less than or equal to n Cik, this is a C, let us take C, Cik plus g of k comma v minus 1 comma k. So let us take this is an equation 1. So by generalizing these equation we will get g of I comma s. I is a starting city, starting vertex, and s contains a set of cities, set of vertices, is equal to minimum of j belongs to s. Let us take j. So I is one city and j, let us take j, means other than the starting city. I is a starting city and j is other than the starting city that belongs in a set. Then Cij plus g of I comma s minus of j. So this is a generalized equation for finding the length of the path from starting from the vertex. So let us consider one example so that we can find out the minimum cost for the tour for the traveling salesperson. So that I will explain in the next video. Thank you.